Hi. In our last class, we started looking at molecules and chemical reactions. In today's class, we will look at molecular formulas and empirical formulas. For molecular formulas, for example, for water, the molecular formula is H2O. There are two hydrogens and one oxygen in every water molecule. For ethylene, another molecule, the molecular formula is C2H4. There are two carbons and four hydrogen atoms. The empirical formula is the ratio of the atoms of the elements in the molecular formula. The ratio in water is 2 parts hydrogen to 1 part oxygen. So the empirical formula is the same as the molecular formula for water. But for acetylene, the ratio carbon to hydrogen is 1 to 2. There's a common factor of 2. So the empirical formula for ethylene is CH2. And today we're going to be looking especially at empirical formulas. And that's because there's a method of finding the empirical formulas for new compounds. And that method is called combustion analysis. And to explain the method, I think it's easiest to look at a problem. A compound in lime rinds has been found to inhibit skin tumors. 18.269 grams of the compound. When completely combusted in pure O2, that means it's burnt in O2. The chemical reaction is O2 plus the new compound. React, so reaction is the arrow, to make CO2. It makes 42.452 grams of CO2 plus H2O, 6.6850 grams of H2O. Those are the only two products, and the question is, what's the empirical formula? So the only products have CO2 and H2O. The only three possible elements that we reacted are C, H, and O. So this new compound, whose empirical formula we don't yet know, can only consist of the three atoms C, H, and O, because those are the only three atoms in the products. To solve this problem, we are going to use the mole concept. And we will convert to moles. So we know that the molecular mass of CO2 is 44.01 grams per mole, and the molecular mass of water is 18.02 grams per mole. We know the number of grams, we know the molecular mass, we can convert that into moles. This is 0.96460 moles of CO2. And this is 0.37098 moles of H2O. And if we know the number of moles of the atoms, we can produce the number of grams, the number of moles of carbon and hydrogen. We have 0.96460 moles of carbon. And there are two hydrogens for every for every mole of H2O. So we have 0.74195 moles of H, since there are 2 moles of hydrogen atoms for every 1 mole of H2O. We're getting close to the empirical formula, but we haven't yet gotten the number of oxygen atoms. And the way to do that is that we need to use the final piece of data, the number of grams. And what we're going to do is, we know how much carbon we have, how much hydrogen we have, and we know the total weight. So if we figure out the weight of the carbon and the weight of the hydrogen, we can subtract that from the original weight of 18.269 and get the weight of the oxygen. And so we'll do that right here. Carbon is 12.01 grams per mole. Hydrogen is 1.01 grams per mole. We have the moles, we have the atomic masses. We can calculate the grams of carbon. It's 11.5848 grams of carbon, and we have 1.01 grams per mole for hydrogen atoms. That's 0.74937 grams of hydrogen, since we know the number of moles. We're going to add the number of moles together. So we'll add these number of moles together, grams together, and we're going to subtract that. Subtract those number of grams from the grams of the compound, and that will give us the grams of oxygen, since we've now taken out the carbon and hydrogen. And when we do that subtraction, we end up with 5.93483 grams of oxygen. And we can convert grams of oxygen to moles of oxygen. Oxygen is 16.00 grams per mole. That's 0.37093 moles of oxygen. And we now have the numbers that we need. We have the moles of oxygen in the compound, we have the moles of carbon in the compound, and we have the moles of hydrogen in the compound. And I'll write these numbers right over here. Carbon, we have 0.96460. Hydrogen, we have 0.74195. And oxygen, we have 0.37093, where I've just copied these 3 numbers. Now, empirical formulas are in integers, so we need to convert these decimals to integers. And so what we're going to do is divide each of these 3 numbers by the smallest of the 3 decimals, which is the oxygen number, 0.37093. And when you do that, you find that it's carbon 2.600, hydrogen 2.00, and oxygen 1.000. We can convert 2.600 to a fraction. By mental math, we know that is 13/5. Hydrogen 2, oxygen 1. And now we can get whole numbers by multiplying everything by 5. C13, 13 over 5 times 5. 2 times 5 is 10. 1 times 5 is 5. And this is the empirical formula for the compound found in lime rinds, which inhibits skin tumors. And we'll practice finding empirical formulas and combustion analysis tomorrow.